So with this section, we're going to be talking about 11.3. In this section, we're going to be discussing more in depth about expected value. And here's the little formula that you're going to be using for expected value when the directions ask for this particular um, example as far as expected value. So for this one here, as you notice in the problem, we have P and A. The P always kind of represents the probability, and then the A actually represents the actual whatever the actual number. So there's always going to be some multiplication involved, plus another set of probability in the actual number, plus and so forth, all the way down. So depending on the word problems, how many you will have. So let's talk about a few examples before I take you to my MathFlash Plus. We're trying to do a test taking strategy, and Maria is trying to determine about multiple choice exams. There's 5 possible choices for each question, and the instructions indicate that we'll be awarded 2 points for every correct response. If she gets it right, she gets 2 points. She will actually lose a half a point if she gets it incorrect, and she would be rewarded no points, will be added or subtracted if the problems are left blank. So if Maria does not know the correct answer to a question, is it her to her advantage, or what would you tell her to actually how to guess the answer? Is it her advantage to try to guess the answer or leave it blank? So let's kind of put it into the equation. So guessing correctly, remember there's 5 multiple choices, so there's 1 out of 5 chances for her getting it actually right. There are actually 4 out of 5 chances for actually guessing it incorrectly. So remember, she's get 2 points if she guesses correctly. So this is the probability times the actual number. That's that P1 times the P1 minus the A1 plus 4 out of 5. So this is the second probability. And then remember, it's a -1/2 because she gets it wrong. She gets minus a half a point. So we multiply these two together and get 2/5. Multiply these two together and get 2/5 again. 2/5 minus 2/5 is 0. So what is the conclusion to this? If she does not know the answer for or disadvantage for guessing, there's no expectation as far as there's zero expectation for her if she guesses. Therefore, over a long run, she would neither gain or lose any points by guessing. So pretty much if she guessed the whole test, she's not going to gain or lose any kind of momentum as far as getting a good score. So let's change it up a bit. What if she can actually eliminate one of the possible choices? So out of the 5, she can eliminate one choice. Now we're down to 4. So that she has a 1 out of 4 chance of getting it right and a 3 out of 4 chances of getting it wrong. So we do the same probability, her reward, her penalty. In this case here, if we actually multiply these two together and multiply these two together, subtract them, we have 1/8. So what does a 1/8 mean again? So since the expectation is a positive 1/8, not a negative, Maria actually on average would gain an eighth of a point each time she guesses. So anytime she guesses now, if she can just eliminate one choice, it boosted her 1/8 of a point in the long stretch. So that's probably her best strategy now is if she can get rid of one, truly know that one of them is not the right answer, and then she guesses on it, she gains at least a 1/8 of a point of trying to get a possible choice right on the for her score increasing. So let's try this one here. So just pretend that you are a organizer for a concert coming up. The you as far as here would estimate that there will be 20,000 people will attend if it is not raining, and 12,000 people will attend if it is raining. So this is not raining, this will be raining. So on the day of the concert, the meteorologist predicts that there will be a 30% chance of rain. Determine the expected number, because we had that expected, remember that's where we're going to go to the expected value formula, of people will attend this concert. So remember, if it does not rain, we know 20,000 people is going to show up, and then we're going to multiply by 0.7. So where do you think the 0.7 came from? Remember, the meteorologist says there's a 30% chance that it will rain. Well, if it's a 30% chance that it will rain, it's probably a 70% chance it will not rain. So the 70% not rain goes with the people, that's all the people that said they were attend, the 20,000 said if it was raining. Multiply the two together and add it to, if it does rain, remember 12,000 people is going to show up. So we multiply these two. So remember, in this particular formula, we're going to have a probability always times the actual number. Probability times the actual number, and make sure they go together. Not rain, 20,000 people said it will come. Will it rain? Then we have 12,000. Multiply them together, add them, and we get at 17,600. So because the meteorologist said there's a 30% of rain, we can probably expect 17,600 people will actually be in attendance of this concert. Crazy, right? We can actually figure it out by just working this expected value formula. Fair price now. This if you want to kind of relate the fair price to something, I would say going to the amusement park or a state fair or something like that, and you playing one of those games. So let's kind of look at one of those games. At a game of chance, there's expected value is found that to be negative $1.50, and the cost to play is $4. Determine the fair price. So we need the expected value. So this time here, we have the expected value. So they actually worked the problem out and got you the expected value, but we need to add it to the cost of play for fair price. So for here, nothing to it. The expected value, which is negative 150, plus the cost of play, we have $2.50. So the fair price to play this game is $2.50. So what do you think that means? So I kind of look at this as when you go into the state fair and I want to play, I love basketball and playing little basketball hoops, but every time I go there, every time I see the basketball hoops are bent. They're like a small little hole. So it's one of those things where the cost to play it is $4 to give them a basket to shoot the basketball, but the expected value of me actually making it, that's that minus $1.50. So really, they should be charging me $2.50 to play this game, as far as the fairness of the game and the bent rim and me paying for them to play. But it is what it is. I love the joy of playing it, so hopefully to win a big stuffed animal. But besides the case, this is how we understand the fair price of a game is really supposed to be $2.50. They bent the rim a little bit too much. All right, so let's move over to the DMA homework, and I want to do at least one problem just to kind of show you how the setup is going to look like. Do number 16. So once again, looking at the problem, a coffee franchise is opening a new store. The company estimates there is a 65% chance the store will have a profit of $65,000. There'll be a 20% chance that the store will break even, and there will be a 15% chance the store actually will lose $30,000. So what is determine the expected gain or loss for the store. So again, we have that expected, so we're going to be using the expected value formula. Remember, we always need what two things do we need to be multiplied together? We need a probability or percent and time the actual number. So make sure they always match up when you put them together. So looking at the problem here, 65%. So remember how to change a percent to decimal. You can just divide by 100 or move the decimal 2 places to the left. Is 0.65 times the actual 65,000. So, and then we have plus 20% will break even. So when it says break even, that means the actual dollar amount will be zero. That means we gain no profit, it's just we break even. So we multiply them two together. And then the 15% changes to 0.15 and lose, this is where we use the negative sign now, $30,000. So we do the math, multiply them together, we get 42,250 plus 0 plus a negative 4,500. Add them all together. and we get 37,750. So there's that. Therefore, the expectation is 37,750. So I hope this helps for section 3, and let me know if you have any questions.